Okay, for today's notes, we are going to do some review, but we're going to use this review time to make sure that we prepare a study guide for the upcoming assessment and the end of the year final. So some things that we can definitely expect to see on the end of the year study guide is the first derivative test and the second derivative test. So we're going to start by annotating some keywords in each one of those. So remember that the first derivative test just tells us the slope. All right, so this is going to tell us basically increasing versus decreasing intervals. And remember, those are going to be intervals, so from like where to where. It's also going to tell us some relative minimums and maximums. And I'm going to underline relative there because we have a different test for absolute minimum and maximum, the extreme value theorem, that we'll talk about later. Okay, the last thing that you could potentially write here is critical points, or critical numbers, or critical values. Remember, that's just when the derivative is 0. Okay, and some other things that I just want to make sure that we really understand is that when f prime is positive, so what this is actually telling us, the first derivative test, is if we find that f prime is positive, that tells us that f is increasing. If f prime is negative, that tells us that f is decreasing. Okay, simple enough. But some other things in here, it could also tell us minimums and maximums. So if we see that f prime changes from either positive to negative or negative to positive, that tells us something. So let's say it changes from positive to negative. All right, it's going up, then it's going down. That's going to tell us that f has a max. All right, but if f prime changes at some point from negative to positive, so think about that, going down to going up, that's going to mean that f has a minimum. Okay, so sometimes we'll just be asked with finding increasing, just identifying intervals for which something is positive, decreasing, identifying negative, and maximum, we can see that there's actually something a little bit more to this where we actually have to find where it changes from one to the other, and vice versa. The second derivative test, remember, is used for concavity. So this is going to tell us concave up versus concave down. All right, so remember that concave up kind of looks like that, concave down kind of looks like that. It could be just part of that, right? We could just see kind of half of that. We don't need the entire horseshoe or U in order to find concavity. It's also going to help us find inflection points where it changes concavity. All right, so one thing that we want to annotate is if f prime is positive, that indicates that our original function f is concave up. So that's the difference. And if f double prime is negative, that tells us that f is concave down. And then lastly, for inflection points, that would be if f double prime changes concavity. And it doesn't matter if it changes from positive to negative or negative to positive. If it changes concavity, it's going to be an inflection point. And I should say f has an inflection point. And there's another kind of caveat here, is that f double prime also has to be 0 to get an inflection point. Okay. So if I see that f double prime changes, like 99% of the time, it's going to automatically be an inflection point for f. But I just want to make sure that f double prime is differentiable and that the derivative is 0 at f double prime. So this is going to help us because if I'm looking at a test really quickly and I see a problem that's asking me for relative minimum or maximum, I can immediately see first derivative test. If I'm looking for things that say, okay, concavity, concave up and down, I'm automatically looking for second derivative test. So we have a test question type thing that looks like this. Let f be the function defined by this, 3x squared minus x to the third. What is the largest open interval on which the graph is both concave up and increasing? So I need an interval, so my answer is probably going to look like parentheses. And I need it to be both concave up that tells me, let's see, concave up. So if I need f to be concave up, that tells me I need f double prime to be positive. So that's the second derivative test. And increasing. So if f is increasing, that means I need f prime to be positive as well. So one of these is going to be first derivative test. One of these is going to be second derivative test. You might be thinking, well, which one do I start with? We'll start with the first one. You're going to have to do both derivative tests. We should start with the first derivative test anyways. So the first derivative test is going to look like, well, just finding the first derivative. Okay, so if I start with f of x equals 3x squared minus x to the third, f prime is just going to be the derivative. So that's going to be 6x minus 3x squared. If I factor that, getting ready to solve this, I can factor out a 3x, and we would get 2 minus x inside those parentheses. Now what we're ready to do is solve for those critical points by setting this equal to 0. And I get two solutions, one for this product and one for this product. So x equals 0 here, and x equals 2 here. Think about plugging in a 2 for x. That would give me 2 minus 2, which is 0. All right, so now these are our critical points. So that's going to be when our derivative is 0. So remember that this isn't our answer. This kind of just sets the boundaries for when things are increasing and decreasing and when they might change from increasing to decreasing. These are our horizontal tangents. So to actually figure out if it's increasing or decreasing, I have to plug in a number from negative infinity to 0, from 0 to 2, and 2 to infinity. Think of these as our test values. So our test values are going to be, let's say, negative 1, 1, and 3. So all we need to do is find the derivative at those values. So f prime of negative 1, f prime of 1, and f prime of 3. So when I'm finding my f prime values, I'm just going to use my derivative that I already found up there. So we're just plugging those in. So I'm going to get something like 3 times negative 1, and then 2 minus a negative 1. Well, remember that that's going to turn into a positive there, and this is going to be a negative product there. So the product of a negative and a positive is always going to be a negative. That tells me that we're decreasing from negative infinity all the way up until 0, and it's going to stop decreasing at 0. At f prime of 1, same thing. Plug in a 1. And this time we're going to get a positive product there, and 2 minus 1 is going to give us a positive there. So this entire product is going to be a positive. So everything from 0 to 2 is going to be increasing. And then lastly, we're going to do the same thing with 3. And we see we get a positive product there, and then 2 minus 3 is a negative. So the product of a positive and a negative is going to be a negative. So we're decreasing there. So remember that what we were looking for here was where is f prime going to be positive? I'm doing my first derivative test. I found it here in this interval. So f is increasing from 0 to 2. That's just a quick annotation to myself. I'm not done yet. Because I also need to find where f double prime is positive. So we already found that f of x equals 3x squared minus x to the third, and f prime was 6x minus 3x squared. So now we got to find f double prime by taking the derivative of that. All right, so remember, this is our second derivative test. This is for finding our concavity. All right, so maybe if I just draw an arrow here. Okay, so now from here, if I were to solve this by setting it equal to 0, I'll save you the math here. We'd subtract 6 and divide by negative 6. We'd get 1. Okay, so now this tells us a possible inflection point, because this is going to be a point that has a second derivative of 0. So now once again, we still have to choose some values to test on either side. Let's say 0 and 2. And we're going to find the double prime values of each one. This is going to allow us to see positive, negative, which in this case is going to tell us concavity. So if I plug in f prime double prime of 0, I get 6 minus 6 times 0, which is just 6 minus 0, which is 6. And f double prime of 2 is 6 minus 6 times 2, which is 6 minus 12, which is negative 6. So in one case, I get a positive. In the other case, I get a negative. So which one of these would be concave up? Let's see, that's when f double prime is positive. So that's from negative infinity all the way to 1. Well, they were asking us, okay, which open interval, which largest open interval would be both? So we have to figure out, is there any overlapping here? Are there numbers that are included in both 0 to 2 and negative infinity to 1? Well, let's see. Negative infinity is all the way from left and ends at 1. This one goes from 0, goes through 1 to 2. So which of those are actually used both times? And it looks like actually from 0 to 1 in this one and in 0 to 1 for this one. So 0, 1 includes both. And that would be our answer.